Hi guys, welcome to the Numpy Essentials lecture part 2. In this lecture, we are going to talk about a few other very important concepts such as indexing, slicing, broadcasting, and Boolean masking. We will learn how to reference elements within an array and how to assign values to the elements within an array. So we will learn how to select element or a group of elements from NumPy array. We will talk about broadcasting, a very new concept at this stage. Boolean mask or masking operations. We will do some masking in this section as well. Once again, this notebook can be considered as a reference to the video lecture, and you can come back anytime if you want help. So we can either create a new notebook or we can move on with the previous notebook what we already have. Now in this notebook, we don't need to import NumPy because we already have imported NumPy as NP. If we are creating new notebook, we need to import NumPy again. Let's create a simple one-dimensional NumPy array. We can use arrange or we can create using list. So array, we call this array 1D equal to np dot array, and we can let's pass in a list here -10 -2 0 2 17 106 some random numbers and 200. Let's run this cell and see how the array look like. Array 1D. So here it is. We have array -1 -2. This is what we have created now. In the simplest case, selecting one or more element of NumPy array looks very similar to Python lists. Like if we want, let's copy this one, and if we want say 0, here it is. At 0 index we have -10. If we want a slice or a range, like let's copy this thing here and say we want 0 to 3, it's the same as list. Let's print this array along with this one just to compare. So this is same at list. So from 0 to 3, but third index is not included. 0 1 2. So 0 to 3, then with -2 and 0. So we can use negative indexing as well. Let's copy this code, paste it here, and enter say -2 or -1 -2. So here it is 106 from this array, which is -1 and -2. And in the similar way, what we did with Python lists, we can say colon 2. Let's see what it is giving us. So anything from 0 index up to 2, but 2 is not included. 0 1. So 2 index is 0, which is not included. And the same way, if you remember, we can say kind of 2, and we don't pass anything here. So in this case, anything from 2 to onward in the list, 0 0 1 2, this is 2, and everything after that one. So let's do another thing here. Let's pass in index 100. Do you think you have any index in array which is 100? No, we don't have. Let's see what the output is. Okay, so if there is no index present in the array, so we are getting index error. Let's create a two-dimensional array with say 25 elements using arrange and convert that into 2D matrix. And we can do this thing actually. We can create array 2D equal to np dot a range 24, and let's print this after its creation. So we have a one-dimensional array. So what we want two-dimensional array. We can use reshape here, say 6 4, and here it is. We have two-dimensional array with 0 1 2 up to 23 with 24 elements. So to access any element, the journal format is array 2D. We pass in row and then we pass in column. So if you want 1, so the row is 0 and the column is 1. Instead of passing row and column in two square brackets, we can use another notation. We can say comma separated row and column as well. So let's try to access some elements in this array 2D. So if we want, say 2 2, we have 10. Let's see where the 10 is. 0 1 2 0 1 2. This is 10 here. We can do array 2D and pass in 1, and it's going to return the whole row, actually a complete row, 4 5 6 at 1. So another way is like we say row equal to 2, col equal to 3, and then we can say array 2D and then pass in row col. It's simply like assigning values to the variables and passing those variables, and we are getting 11, which is 2 3. So 2 3, row 2 0 1 2 and column 3 0 1 2 3. This is 11 here. We can pass in array 2D and say we can pass in like 2 to 4 for rows and say 2 to 4 for columns. Now we're getting elements from 2 to 4 in rows and 2 to 4 in columns. So it's a two-dimensional matrix in the output, which is a part of this matrix. So moving forward, let's talk about a very interesting and very elegant concept in Numpy: broadcasting. Numpy arrays are different from normal Python lists because of their ability to broadcast. We will only cover the basics on broadcasting in this lecture. You can explore more by opening the provided link in the reference notebook, and this one is a very extensive documentation on broadcasting. If you want to know more about broadcasting, you can read with examples on the NumPy's official documentation. So let's start with a very simple example. Let's create an array 1D np dot a range, let's say 0 and 10. Let's see how this array look like. So here we have a one-dimensional array from 0 to 9. Let's take a slice, array 1D 0 to 5, and broadcast a value, say 500, and run this cell. Let's see how this array look like now. So here it is. The first 5 values are now 500. So we only broadcast this value on a selected slice and all the values are changed. Let's try to learn with another example using two-dimensional array. Array 2D np dot. Let's say we can create an array of ones and say 4 by 4 matrix. See how this array look like. So here we have 4 by 4 matrix. Let's broadcast some value to say first row only. We can do this thing, array 2D at 0 index, which is the first row, equal to say 300. Run this cell and see what is changed. Here it is. So with only a single statement, the whole row is changed. Let's create another array. ARR equal to np dot a range 0 4. Let's see how it looks like again. So we have 0 1 2 3. So it has 4 columns and 1 row. Let's add this array to ARR and see what we are getting. So this one-dimensional array is broadcasted array-wise from top to bottom. Let's try to understand this broadcasting concept from a visual example. Let's go back to the reference notebook. So where we have a very good example, like in this one, if we look at the first row, we have 0, 1, 2, 3 elements in one-dimensional array. So if we want to add a single element 5, this is broadcasting. So 5 will be broadcasted over this one-dimensional array. So we will have 5 plus 0, 1 plus 5, and 5, 6, 7. So if we have two-dimensional matrix, like 3 by 3 in this case, with all ones, and if we want to broadcast one-dimensional array with 0, 1, 2, this will be broadcasted across the rows. So all of these rows will be affected. 0 plus 1, 1 plus 1, 2 plus 1. 1 2 3 1 2 3 1 2 3. So in the third one we have a column 0 1 2, and we want to broadcast an array 0 1 2 on this column. So this is quite interesting. If we broadcast a column on a single row, what we are getting 0 0 0 0 1 1. So this first row all will be considered at 0, and they will be added according to the given operation 0 1 2 0 1 2. In this case, second element in the column is 1, so all across the row will be considered 1. On the other hand, this whole row will be considered in the second place as well, and we will get 1 2 3. And same as in the third row, 2 2 2, and in the second, and here it will be considered 0 1 2, and we are getting 2 3 4. So let's move back to the notebook and learn with another example. Say if we want to broadcast 2D and say 300 on this whole 2D array, let's see how it looks like. So we are getting 300 plus 300 600 600 600 301 301 301, because these are all ones. This 300 is broadcasted over two-dimensional matrix. Let's try another examples. We have air, which is 0 1 2. We create another air 2 equal to np dot a range, say 0 and 4. And now we want only a column actually. So we'll pass everything in the first place at row np dot new axis. So every time it should give a new axis. Let's see how ARR2 looks like. So we have 0 1 2 3 0 1 2 3. So let's broadcast ARR to ARR2. So what we are going to do, ARR2 plus ARR, and let's run this cell and see how it looks like. So this is what it is. So what we are getting, 0 1 2 3, this whole row will be considered 0, and this single row will be broadcasted on this row. And in the second case, 1 plus 0 1, 1 plus 1, 2, 2 plus 1, 3 plus 1. So the elements that don't exist will be considered 1. So again, for third row, for third row, 0 plus 2, 1 plus 2, 2 plus 2, 3 plus 2. And for the fourth row, 0 plus 3, 1 plus 3, 2 plus 3, 6. So this was all about broadcasting at the moment. I hope you got an idea how the broadcasting concepts work in NumPy arrays. So let's move back to our working notebook and discuss another important concept, fancy indexing. So what is fancy indexing? Fancy indexing actually allows us to select entire row or column out of order. To do this, let's create a matrix. I will use the code from the reference book to create a matrix here. Copy this code, paste it here, and let's run this code. So this code is going to generate a matrix with 0, 1, 2, 3, and 4 rows with all zeros, all ones, all twos, all threes, and all fours. So I can grab any row, like if I pass in a list of 1, 2, 3, I want row 1, 2, 3 in the output. I can just pass in a list and grab this row 1, 2, 3. I don't need to mention the order here. So I can grab the row in random order as well. Like if I want 3, 0, 1, it's going to return 3, 0, 1, and so on. Let's create another matrix and use fancy indexing on that matrix. I will copy again the code from the reference book. So this is very simple. I'm creating a two-dimensional matrix with a range 24, giving a shape 604, and then printing it. So I have 0, 4, 8, 12, 16, 20 in first column, and it has 6 rows and 4 columns. So let's grab a row in this matrix. Let's say I want to grab a row 2 and 4, pass in the list 2 and 4. I'm grabbing second and fourth, 0, 1, and 2, 3, and fourth. I can grab in random order as well, like I pass in 5, 0, and say. So I have 0, 1, 2, 3, 4, 5, and 0, the first one. So I can grab the columns as well in this case, like I can pass in array 2D and everything, and then pass in the columns here. Like this means all rows, and pass in the column. Say I want 2 and 3. Here it is. I have second 0, 1, 2, and 3. I can pass in randomly as well, like 3, 0, and I have third column here, 0, 1, 2, 3, and 0th, this one here. So this was all about fancy index, where we don't need to worry about the order, and we can call complete row or complete column in a random order. So let's move on to the next topic, which is Boolean masking. So Boolean mask is a very useful and handy when it comes to count, modify, extract, or manipulate values in an array based on some condition or criteria. For example, we want to count all the values greater than a certain value, or we set a threshold and want to get rid of outliers in our data. In NumPy, Boolean masking is often the most efficient way to accomplish such tasks. Let's start with simple example and create another array AR1. Once again, we can use np dot arange, and let's say we want 1 to 10. So always good idea to see how the array look like when you have created. So we have array 1 to up to 10. We can apply conditions such as greater than, less than, equal to, etc. Let's create a Boolean array for some condition. Say array, say the array 1 is greater than 3, and let's say so bool mask equal to, what is our condition? What is our condition? Array 1 greater than 3. So we have created Boolean mask. Let's see how this Boolean mask look like. Here it is. So it has false and trues. If we compare array to this Boolean mask, the condition is array 1 is greater than 3. Is this 1 greater than 3? No. 2? No. 3? No. And this is where the condition is satisfied. And all these values from 4 to upward till 10, we got true, true. So this array bool mask is an array with false and trues, and we got a masking in this array. We want to mask even number or odd numbers, so we can use modulus operator. So let's create a mask here again. Say mod 2 mask 1d equal to 0 r1 mod 2. So if we run this thing and then we run this mask, so we have created a mask for list in R1 where the modulus equal to 0. So we can use these masking arrays to do masking operations. In masking operation, we simply index on the Boolean array, like on this array or this array bool mask. All the values in position at which the mask array is true that we will get in our output. Let's try to do this thing using mod 2 mask id on array AR1. So even values we want to do R1, and what we do, we pass in this mask, and let's print this one as well. So here it is. So we are filtering out the odds using this masking array in our array 1. So here it is output, which is only the even numbers. So let's check with two-dimensional array and create a 2D array using np dot arange, say 24, and then array 2D sets is, then array 2D dot shape equal to, if you want 6 to 4, and we want to mask mod 2 2D equal to 0 equal to, this is the array we have created, mod 2. So we want to have all the even values in our output, and we are creating a mask where array 2D mod is equal to 0. This is our condition. So let's run this code, and now let's print array 2D, and let's print this mask as well. Here it is. Now For all even values, for 0 it's true, for 1 it's false, for 2, 6, 10 it's true and it's false. Let's filter out the values now using the mask what we have created recently. What we need to do, we need to take this array and take this mask, and here it is. Run the code and we are getting 0, 2, 4, 6, 8, 12, 0, 2, 4, 12, 16, 20, and so it is actually the column 1 and column 3 where the condition is satisfied, and we are filtering out all the values which satisfy this condition in our mask. So this was all about masking. Excellent job, guys. We have gone through several very important concepts in this lecture regarding NumPy. All these concepts, we are going to use them in the coming lectures. Please go through them once again, follow the lectures, and try to revise all these concepts. In the next lecture, we are going to explore more about NumPy. See you in the next lecture. Good luck.